Okay, I haven't done all the details of proving this is true, but I'll point to them. Okay. First of all, A is the matrix we got over here that transforms the vectors, the basis vectors in the B basis to combinations of basis vectors in the B hat basis, B tilde basis. And that's this, and that really is just, you can see the vectors in the B hat basis right here. You know, x plus 1, x squared plus x, x squared plus 1. Okay? Right in there. Okay, so up here, we take this same expression here and show that that's equal, at least outline how we show that that's equal to A inverse times the matrix we get from these three columns multiplied by your alpha, beta, gamma. Okay? Now, the one step that's pretty clear is that multiplication by alpha. Now, there's an objection. Somebody said, wait, you can't do that because matrix multiplication isn't commutative, and that was a good observation. That ought to be a red flag when you write this down. But this isn't a matrix. Okay? And by the linearity, scalar multiplication, and all that, it works out. Basically, you multiply A inverse by this, you get something, right? Then you're going to then multiply by A. Well, you might as well multiply alpha. You might as well multiply this by alpha before you multiply by the matrix. It comes out the same. And just one of the basic properties of matrix multiplication. And then, when you add these, well, make sure I've got the right matrix up there, yeah. When you add these, it comes out this way, okay? But okay, and this matrix, of course, is the matrix of your columns of your B basis, right? Okay? So, we have the two matrices, and we're doing the inverse of this matrix times this matrix, right? This is the columns of your B prime matrix. This is the column of your B tilde matrix. This is columns of your B matrix, right? Okay? So somehow those two become involved in making the transformation. Okay? So it comes down to transforming from your B basis vector to your B tilde basis vector. You multiply by the columns representing your B basis, multiplied on the left by the inverse of the columns of your B tilde matrix. So we want to put that into some kind of notation to give us a concise statement, picture of what's going on.